Today, we're going to be talking about something that's pretty hot right now. We're going to be diving into the world of MLOps.
Oh, yeah.
And
It's
specifically,
a good one.
we're going to be looking at professional certifications
Yeah.
in this field.
Nice.
Yeah.
MLOps is,
If you're out there and you're thinking about maybe getting a certification in this space,
yeah.
this is the episode for you because we're going to be talking all about what it could mean for your career.
Okay, so today we'll get into the algorithm session. So one of the most important algorithm which we have, which you have to interact on daily basis with while implementing the MLOps is Scikit. Okay, so Scikit-Learn we call it, Scikit-Learn. So today we'll try to explore Scikit-Learn for machine learning. So as part of it, this session we'll discuss about Scikit-Learn for data and ML modeling. Now, what are the relationship of Scikit with NumPy, SciPy, Pandas, and Matplotlib, and algorithm for supervised and unsupervised learning? And then we'll also discuss about the context of this algorithm with TensorFlow, Keras, and other deep learning framework. So this is something. Now, this is one of the good image in order to visualize what you can do. So for example, let's say if you want to implement the AI ML, uh, so TensorFlow is basically build and deployment models for deploying models. Here we focused on the Qflow, which is more popular than TensorFlow, which I discussed in the last session. PyTorch, flexible for research. Scikit-learn, versatile algorithm collections. Keras is switched for neural networks. That means I'll discuss about this. What is the difference between Scikit and Keras neural networks, and the Jupyter notebook, which we covered last time. Right side also, if you see that primary use like Python with pandas can be used for data manipulation. Python with Scikit can be used for machine learnings. Python with TensorFlow can be used for deep learning. Python with Matplotlib can be used for visualization. So Matplotlib, Pandas, and one more algorithms. We have shown you the demo last time also. Flask is for the web development. Pygame if you want to get. So these are the major libraries which we have. Okay, so these so in the machine learnings we have a phases actually. First thing like gathering the data. Okay, gathering the data and then processing the data. We call it a web scraping also, because most of the time we gather the data from the scraping. So there are so many libraries which you can see that left side you have modules in Python which can use it. For machine learnings anyways we discussed. For the data visualizations again number of tools which we have. For neural learnings also so many tools and so many models we have actually. For data manipulations also there's so many algorithms left side you have, and statistical analysis. So the plenty of things are there. We should not get confused. So what are the prerequisite in order to learn these are the models, these are the algorithms. So basic Python programming is required, and you can be new in MLOps and stuff like that. So it's not a required thing. Okay, so what is a algorithm? So machine learning algorithm is an algorithm that is able to learn from data. Yeah. So in simple way, you should be having lots of data, and then these algorithm will learn from the data and then give you the some output. Now this learn from the data, this algorithm for learning the data, you can select this algorithm, and there are ways to automatically also algorithm can decide which algorithm is the best suitable for this kind of data. So lots of data is required. So yes, if you see that here, machine learning works with a huge image of data, and then algorithm make find a patterns for it, and then based on that pattern, it will help you to make a intelligent decisions of it. Okay. For example, there is a emails on the server, so you have a huge amount of emails, maybe 10,000, 20,000 emails you have in your box, and you need to find out whether the emails are spam or ham. Okay, and that is like a algorithm you need to run. Based on the algorithm they will find a pattern, and then action which you can suggest, like make intelligent decisions whether you want to trash, keep it in trash or in box. So whatever the email. So these are the kind of things which is done by machine learning. One more example which you have is like here, you have a plenty of images, and that images can be anything: dog, animal, houses, and different objects. You may have a thousand and thousands of images of different one. Now you have to identify the images, age, color, and shape, and you will need to only find out the one image which is a girl image. Probably if you do that in Google, you search for that girl image. How do you get that only girl image? So there must be some logic, right, to decide that okay, it's a girl image or boy image or something else, right? So that way, you can use the machine learning for that. So now, which are the kind of problems which we have in machine learning? This we discussed in the first session also, but here we need a little bit of context to discuss Scikit-Learn. So these are the four types of problems which we have while implementing the machine learning: classifications, regression, clustering, and dimensionality reduction. So we'll focus on the classifications first, but yeah, let's discuss about this. How do you know? There's a one example here. How do you know whether the whales, whether it's a fish or mammal? Okay, so what are the parameters you will have to consider that? So mammal, you know that members of infraorder, uh, cetacea, and fish look like fish, swim like fish, and move like a fish. So how do you now, like whales? Whales is also can look like a fish, swim like a fish, and move with the fish. That is correct. But whales is a mammal, right? It's not a fish. So how do you take a decisions on that? So yes, if he's a human expert, he will have a certain logic, which you can call it a rule also. If I ask you, whale is a human, whale is a mammal or fish, so you'll say fish. Oh, sorry, you'll say mammal. Why? Because in your mind you have a certain data, certain rules to decide whether it is a mammal or a fish, and based on that you decide that, right? So something like that. Now we need to replace this expert which is working on the rule based to the algorithm. Okay, so now you have a corpus of data. Okay, where you have a hell lot of different kind of mammals, different kind of fish, and then you have a corpus of data, and then based on that you build the classifications, mammal based classification, and then you find out the mammal, whether it's a mammal, and for that those rules you have to define for the algorithm. Now the question is how these rules will be decided. So these rules will be decided based on the training and prediction. The question is, how did you learn? You learn because of someone has taught you over the period of time, multiple years, and then based on that you can say, okay, this is mammal or fish, right? So same way, you need to train your model. You first of all, you have lots of data. You have a lots of data, and then you have to train that. Using some algorithm, you need to train that model, and then model will predict whether it's a based on my rule, based on that whether it's a mammal or fish. So that's the prediction will be there. So feed, so you need to train the model, feed a large corpus of data, classify it correctly, and then predict prediction, use it to classify new instances which it has not seen before. Okay, so and that is how you keep doing it. So you have a corpus of data, then you have a ML based classifier, and then you have a classification whether it's a mammal or fish, and then you keep improving the work based on the feedback. For example, let's say if you ask you when you are a 5 years old kid, then if I ask you, then you'll say I don't know, because you have not learned. But after 10 years, if someone asks you, then you can say, yeah, I know these are the points, and I keep improving in order to classify the data. So that is how it is. Okay, so now in order to work with this, so you need a ML based binary classifier where you need to have a corpus of data, and then you run the classification algorithm, and then based on that ML based classifier is decided. Now which are the classification algorithm which we need to discuss in some time. Okay, so this is something which we do that. Now I'm just skipping some of the stuff. Now the question is, what are the difference between the traditional machine learning and representational machine learning? So this is important, okay, in order to understand the scikit. So traditional machine learning, what happens? Uh, you have an algorithm which you decide what algorithm will fit as per the data. So you have a corpus of data, okay, and then you classify the algorithm, okay, and based on that you decide which algorithm, based on the algorithm, then you get output ML based classifier. So that is something which happens. So here you see that specific algorithm which learns from the data, okay, corpus data, and so on. Now there one instance where this algorithm is decided by expert. Mind it, choice of algorithm determined by expert. So that is called traditional machine learning. Mind it again, if the choice of algorithm determined by the expert, this is called traditional algorithm, traditional machine learnings. Okay, so these are some of the models which you have in a traditionals, where you can decide, okay, I understand what kind of data you have, and based on that, if you want to classify, then you can use a naive Bayes, SBM, decision trees, random forest, and many more. Okay, something similar algorithms we have, model we have for the regression also, dimensionality also, and clustering also. So these are the one which we have. Okay, in a Datadog, if you remember, in Datadog DBSCAN algorithm we are using for the clustering techniques. Okay, so now again, what we call it, a traditional machine learning. Traditional machine learnings, we decide what model and algorithm is fit for this data. Okay, that is the traditional model. So here traditional ML model have a fundamental algorithm structure to solve problems. The algorithm is fed data which train the algorithm parameter and called a model parameters. Okay, now this is the one of the very popular image which is developed and shared on the Scikit website, which let's say you have a plenty of data. Now you have to decide, right, which algorithm, which model is good for your data. And this is the one of the popular model which image which you use for deciding which model is good. So let's say if you have a larger than 50k samples and so on, again we'll discuss this one in a upcoming session. But yeah, this is a very popular image which will help you to decide which algorithm is good for you and stuff like that. Okay, so now you understood about the traditional ML models, which is built a tree structure to classify instances, fit a line or a curve on a data to make prediction, apply probabilities on the input data to get output probabilities. Now, you know, traditional ML based system rely on expert, which I shared already, to decide what feature to pay attention and what not. Now, then second model which we have is representational machine learning. Now, representational machine learning, what happens? In a representational machine learnings, you don't decide which model is good for your data. Okay, so here representation ML models also used to solve classification, regression, clustering, and dimensionality reduction. But you know what? Here, this in representation ML model learns significant feature from the underlying data. That means your algorithm automatically learn from the data and then decide which model is good for it. Okay, so that way you don't have to take any decisions here. Based on the data what you get, it automatically it will be decided. Now this it's also considered as like a deep learning model such as neural network. Okay, so representational ML model, you have a deep learning model such as neural network. So representational ML based system figure it out by themselves what feature to pay attention to and how. So in a traditional, you decide. In a traditional ML model, you decide. Representational ML model, algorithm itself decide what to focus on and what to not. Are you getting it?
Yes, yes.
Okay, so now, so one of the most popular models we have in representational is neural network. Neural is a very popular representational machine learning models. So neural network is to help you to deep learning also, and deep learning, which algorithm that learn what feature matters. Neural network, the most common classes of deep learning algorithm, and it has a neuron simple building blocks that actually learn actually. Okay, so this is one of the most popular representational ML based model. And again, neural network model have a multiple layers concept. That means each layers has a certain data and learn from each other. So if you see that image, you have a corpus of data is fed to layer 1, and layer 1 learns something out of it and then pass that learning to layer 2, and then layer 2 also learns something, and this will keep going till you get a classifier or clustering or whatever it is. Okay, so that is something we have. So here layers in a neural network, you have multiple layer, and each layer consists of individual interconnected neurons which basically learning. So these are the blocks which you see, square block. These are the neurons which is learning and sharing the data with each other, whatever. It's like a network of learners. Okay, and then based on that, what happened, just a second, based on that you uh, run the some of the traditional model. Okay, so each layer extract information from the data and so on. So now what are the major difference between the traditional and then representational or deep learning models? So traditional ML model feature used in model explicitly chosen by domain expert. That means you will decide. Whereas in the deep learning ML models, feature used in model implicitly chosen by model itself. Here, traditional ML models structure data such as numbers and probabilities you have it. And here in a deep learning model, you have unstructured data such as images and movies. Okay, traditional ML model classification, regression, clustering, and dimensionality reductions you have. These are the problems you fix in the ML. Same one which you fix in the deep learning model also. So there is no difference here in this case. Okay, so there are few more. Wide range of problem specific solution techniques are there, whereas neuron network by far the most common solution techniques. Okay, so if you go for the traditional ML model, you have so many options. In a deep learning model, you have a limited option, and one of the most popular one is a neural network model. Each solution techniques adopts characteristics approach, whereas in a deep learning models, all solution techniques rely on a neurons and interconnection between them. Again, in a traditional, user has a more insight into mechanics and internals of model, whereas the deep learning model, black box model that are hard to questions or reverse engineering. Now, example for the traditional ML model is Scikit-Learn, and that's what we are trying to cover. So that means Scikit-Learn is a traditional ML model where you decide which model is appropriate for what kind of data, and these are the advantage of it. Whereas if you want to learn automatically from the data, then you have to go move into the deep learning ML models, which like a neuron. Okay, so what are the example for the neuron network model? So some of them, like TensorFlow, have a part of it, not TensorFlow is entirely for the deep learning model. It's for the CI/CD also. But Keras, PyTorch, and all is a deep learning ML models. Okay. So now the question is the niche of Scikit-Learn in a machine learnings. So Scikit is easy to use, very comprehensive and efficient Python library for traditional ML models. Okay. Now who has developed? So this was developed in a Google as a Google Summer of Code project in 2007, and currently you have a 30 plus active contributors, and sponsored by NVIDIA, Google, Tiny Clues, and Python Software Foundations. Again, simple and efficient tool for predicting data analysis, accessible to everybody and reusable in various contexts, built on a NumPy, SciPy, and Matplotlib. Again, NumPy, SciPy, and Matplotlib, I have given you some lab also last time. So if you see that, Scikit-Learn is built on these libraries only. An open source commercially usable BSD license. So yeah, why we are looking for, why we are attracting to others towards the Scikit-Learn. So Scikit-Learn, we have a three major attraction. One of is easy to use. Second one is comprehensive. Third one is efficient. Let's discuss in a detail. So when you say easy to use, then in a Scikit-Learn, you have one API, which is, we call it estimated API. Okay, that means if you want to talk to multiple ML models which is supported by Scikit, you just need to have a one connection, one API call actually, and that's called estimated API. Now anything you want, just you have to connect with you have to call estimated API for this. So estimated API is for the consistent interface. Using that you can do whatever you want. Okay, so estimator for all kind of model. That means whatever the model is supported by Scikit-Learn, you can connect to each models using estimator API. So that way, the complexity of having the multiple interface for multiple model is minimized. That means everything you can get into one API call. Now, what you can do, you can create a model object just using a Python, and then you can start fit to train data and predict for new data, and then you can create a pipeline, whatever it is. So that is easy to use. Now, comprehensive. So when I say comprehensive, then it's support for complete ML workflow. Okay, now in our next slides we'll discuss in detail what are the ML workflow. But yeah, all common families of models supported. Traditional one: data pre-processing, cleaning, feature selection, and interaction are supported, and model validation and evaluation supports. That means end-to-end life cycle. In order to implement the ML, you are having this is support with Scikit. Now, completeness. So completeness means if you want to solve the problem with ML for regression, classification, clustering, dimensionality reduction, everything is covered by Scikit-Learn. Feature interaction, extraction, selection using statistical and dimensionality reduction, data preprocessing, data generation, cross-validation to evaluate the model, and hyperparameter tuning. Everything you can find in Scikit-Learn, this one. Now it's efficient also. So when I say efficient, it's highly optimized implementation. Now this model, I mean this algorithm is built on SciPy, which is like we call it a scikit prefix. Okay, interpolates with all common Python libraries for data science. So that means you can interact with all the other libraries as well. Okay, so some of the most popular which is a part of this scikit is NumPy, which we use in the last session, SciPy, matplotlib is for the NumPy is for the all the numeric data, right? Based on n dimensionality array package. SciPy you can use for the all the scientific computing, mathematical things and all. If you want to have a visualizations and all, some graphs and all, then matplotlib. SymPy, symbolic mathematics, and pandas you have used multiple times. I showed you the demo also for data structure analysis. So these are the ways Scikit is very efficient. Foundation library for Scikit, again these are NumPy, SciPy, matplotlib. Okay, so this is something which you have. Now if you see that these are the kind of visualization and these are the kind of models. uh, I mean, these are some problem statement which you can fix using Scikit. Okay, so this is supervised and unsupervised we have already discussed. So I'll just skip it. In the first session we discussed only. So that one. Any questions so far?
No, no, Raj, I'm clear.
Okay, so now the workflow has to be discussed before I show you some demo and all. So what are the workflows we have? So this is the very popular workflow. I have showed you something similar image in the past also. So these are the basic machine learning workflow, and for each of these stages you have a different algorithm and different tools are there. For example, you have to collect the raw data. How do you collect? Okay, there are so many tools we have available using that. Then you prepare a data, then you clean the data, right? Then you choose an algorithm. Using that you can train the data. Okay, and then you find out the which model is suitable. So in a traditional one you have to find out the model, right? And then you selected the model. So model and algorithm training model training algorithm you have selected. Then you have to validate whether this model on the training is completely happening or not. So choose a validation method. Then you run the validation method, and then you see that whether the output has come as per your fit and expectation. Are you satisfied with the data or not? If you are not satisfied, then again you have to change the model, update the model. And if you're satisfied with this, then keep feeding the more data. So keep learning and then keep doing the prediction. So that is how this workflow will happen. Okay, so remember that these are the stages. Again, let's understand that: collect the raw data, prepare the data, clean the data, choose an algorithm, train the algorithm, fit a model, run the model, choose the validation method, and then examine whether it's good or not, satisfied. If not satisfied, again change the model. If you're satisfied, keep adding the more data and keep predicting it. And that is how it is been done. So these are the basic machine learning workflow. Now, Scikit-Learn has objects and function for every steps in the ML workflow. So whatever we see that here, you have a function, tools and algorithm and model for every stages actually. Okay. So now again coming back to the same image, this representation is like a flow wise, but this is basically it will help you which model is good for what. Okay, so this is a very important image which has been developed by Scikit and floated around the internet. So let's say you start, you don't know what model is good, what you want with the data. So first of all, let's say you start with it. So do you have a data corpus less than 50 samples? Then if you have a less than 15 samples, then try to get more data. But if you have a more data, then what do you want? You want to predict that category of data? Yes. Then you have a do you have a labeled data? Yes. Then again go for the classification. You have a not labeled data, go for clustering. Again, you have a predicting a quantity, then you have to go for yes. Regression, no. Then again just looking or start, then go for dimensionality reduction. So look at this here. If you see, then in classification you have a SBC, ensemble, neighbors, kernel, SGD, linear SB, naive bias, and so many algorithm models we have. These are the popular one as under the scikit-learn. Okay, so this is a very good image in order to decide what kind of data you have and what algorithm is fit for you, and that you will decide as an expert which model is good for you. Okay, so all these models, which are the primary domain which is being used, of course, healthcare, finance, retail, manufacturing, energy, and many more. Okay, now let's discuss about the estimator API. This is the one of the most important one, because this is the only API using that you can talk to scikit-learn algorithm. So scikit-learn algorithm, which is easy to use, very comprehensive, efficient Python library for traditional ML model. Now here we have some example where you are using the estimator basics, and here you are calling that that API, and then you're using it. So some Python program, again we'll run some lab on this. So again, this all official documents only. So if you see that Scikit-Learn provide dozens of built-in machine learning algorithm models called estimator. Each estimator can be fitted in some data using the fit method, and some programs for that. Here is a simple example where fit as a random forest classifier to some very basic data. So if you see that here, you are setting up from sklearn.assemble, importing from that random forest classifier, and some more examples. So yeah, for right now, you need to know only the theoretical part. Estimator API. Estimator API is for the consistent interface, create a model object, fit to training a data, predict the new data, and pipeline for complex operations. Again, it is a principal underlying estimator API is like consistent. You can do inspect, you limited object hierarchy you have in composition, and sensible defaults. These are some more detail about APIs. So this we discussed already. So I'll just do that. Okay, so now we do have a one pipeline in scikit-learn also using estimator objects. So scikit-learn pipeline estimator object that sequentially applies several transform. Pipeline can be over evaluated and turned as a whole. So pipeline also we have, but we'll use the Kubeflow and MLOps ML flow for that. We will not use this one for this. So I'll just ignore it, and so on. So this we discussed, this image only we discussed already. So done. So did you understand that the introduction of scikit-learn?
Yes, yes, I understood. Yeah.
Okay, so next session, what we'll do tomorrow, I will run some of the programs which I have already shared with you last week only. Those programs we'll
Mhm.
learn, and we'll try to experience the scikit, library, different libraries for that. Okay.
Okay, fine.